In this lesson, we'll study some interesting properties of binomial coefficients. Let us consider the expansion of binomial a plus x power n. Consider a plus x power n, and its expansion, binomial expansion, is nc0 a n minus 0 x plus nc1 a n minus 1 x plus nc2 a n minus 2 into x square plus so on, plus ncn into x power n. Here nc0, nc1, nc2 and so on up to ncn are called binomial coefficients. Binomial coefficients. So once you have an idea of what binomial coefficients are, we can explore some of the properties, and those properties will be very helpful in finding solution to many problems in algebra. So property 1 is that we can in fact find sum of the binomial coefficients. Prove that sum of binomial coefficients, is 2 power n. So if we take this equation here as number 1, then substituting a is equal to 1 and x equal to 1 in equation 1, what we get is, if we in equation 1, when we substitute a is equal to 1 and x equal to 1, this of course becomes 1 plus 1 power n equal to nc0. Because a is 1, so any power is equal to 1 again. 1 times 1 plus nc1, again same thing, 1 times 1 plus nc2, that is again 1 times 1 plus so on all the way up to the end, ncn, and 1 power n is again equal to 1. This gives us 2 power n equal to nc0 plus nc1 plus nc2 plus so on plus ncn. This proves the property that sum of binomial coefficients is equal to 2 power n. And let's take a look on the second property, property number 2. And in this property, if we take a is equal to 1 and x is equal to minus 1, let a be equal to 1 and x be equal to minus 1. Then what will happen? On the left hand side here, it will be 1 minus 1 power n equal to, same way it will become NC0 plus, rather it will become minus because x is now minus 1, so minus NC1 plus NC2 plus minus NC3 and so on. The last term would be minus 1 power n NCn. This is so because we don't know if n is odd, then minus 1 power odd will be equal to minus. And the term just before that would be plus minus 1 power n minus 1 into n Cn minus 1. If n is odd, then last term would be negative and term before that would be positive. If n is even, then the last term would be positive and the term before the second last term would be negative. So let's split this into two cases, or rather write it down before we start the distinction even and odd. NC0 plus NC1, this is minus, plus NC2 minus NC3 plus so on, plus minus 1 power n minus 1 NCn minus 1 plus minus 1 power n NCn. And now, depending upon if n is even, then the last term would be positive and the term before that would be negative. So if n is even, this means NC0, keep all the even terms on left hand side, moving all the odd terms on the other side, plus NC2 plus NC4 plus so on, plus NCn is equal to NC1 plus NC3 plus so on, and last term would be NCn minus 1. This means that the even coefficients are equal to sum of odd coefficients. So this proves that sum of even coefficients is equal to sum of odd coefficients, and this is case when n was even. If n is odd, then what will happen? Then the last term would be negative. So if n is odd, then NC0 plus NC2 plus NC4, and the last term would remain negative, and it will move on the other side. So the term just before that, the second last term would be positive, and that should stay here, plus NCn minus 1 is equal to NC1 plus NC3 plus so on, plus NCn. So this is very interesting property, and in both cases the sum of even coefficients of the binomial expansion is equal to sum of odd coefficients in the binomial expansion. And if we take x equal to x and a is equal to 1, so property 3, let a equal to 1, then this would be a plus x would become 1 plus x, and this would become nc 0 plus nc 1 times x plus nc 2 times x square plus nc 3 times x cube plus so on, plus last would be nc n x power n. And if we expand these coefficients, this would be nc0 is of course equal to 1 plus nc1 is nx plus n into n minus 1 over 2 factorial into x square plus n into n minus 1 into n minus 2 over 3 factorial plus so on, plus x power n. That would be the binomial expansion of the binomial expression where a is equal to 1. And property 4, if let a is equal to 1 and x equal to minus x, then the same expansion but only alternating signs will be negative. So this will become 1 minus x power n equal to 1 minus nx plus n into n minus 1 over 2 factorial x square minus, so this must be x cube here. So this is minus n into n minus 1 into n minus 2 over 3 factorial x cube plus so on, depending upon n is even or odd. This will be minus 1 power n times x power n. These are called properties of the binomial coefficients.